Black holes, remains of a massive star. Since their discovery, black holes have piqued the interest of research scientists as among the most interesting and are still being thoroughly investigated objects in space. Since their discovery, black holes have piqued the interest of research scientists as among the most interesting and are still being thoroughly investigated objects in space. Simply described, it's an area in space in which nothing, including light, can evade its gravitational attraction. It's a zone in space wherein gravity is extremely strong, preventing even the tiniest particles, electromagnetic waves and celestial phenomena like asteroids and planets from entering. As nothing can escape these zones, these are referred to as black holes. It can't be seen through human eyes. These black holes are discovered using space telescopes equipped with specialized equipment. If you're still perplexed, consider the following scenario. Consider a star 10 times larger, massive than our Sun, compressed into a sphere of the size of Manhattan. As a result, anything, not really even light, can leave its gravity field. NASA equipment has created a fresh image of these unusual objects in past years, which are considered by many to be the most exciting things in space. Let's have a look at what history has to say about black holes. Einstein's theory of relativity is most renowned for predicting black holes. He demonstrated that whenever a large star dies, it keeps behind a tiny, compact residual core. The equations demonstrated that if the core's size is greater than 3 times that of the Sun, gravity will override all the other forces, resulting in a black hole. The first real black hole was discovered in 1971, after years of only knowing about them as theoretical things. The Event Horizon Telescope (EHT) partnership then revealed the first photograph of a black hole in 2019. While looking at the event horizon, or even the area after which nothing could exit from a black hole, the EHT discovered the black hole inside the heart of galaxy M87. The graphic depicts the emission of photons in a sudden manner, particles of light. Also, it opened a whole new field of research concerning black holes nowadays, that astronomers have a better understanding of what they look like. How do they actually form? A supernova is indeed a star that explodes and sends a portion of its mass across space. The leftovers of a massive star that explodes in a supernova produce the majority of black holes. Smaller stars decay into dense neutrons that lack the density to confine light. It can be demonstrated, conceptually, that no power can protect a star from bursting under the influence of gravity if the entire mass of the star is sufficient. However, something unexpected happens when the star crashes. As the star's surface approaches an imaginary line known as the event horizon, everything on the star slows in comparison to the time measured by watchers far away. Time stops when the surface hits the event horizon, and the star can no longer collapse. It becomes a frozen, collapsed object. There are 3 types of black holes. 1. They might be small but very deadly, stellar black holes. Individual stars collapse into black holes, which are relatively tiny yet pretty dense. One of these things has much more than 3 times the size of the Sun packed inside a city's circumference. This causes a great amount of gravitational pull to be exerted on items in the vicinity of the item. The dirt and gas within their neighboring galaxies are subsequently consumed by stellar black holes, causing them to expand in size. 2. The giants, supermassive black holes. Tiny black holes abound in the cosmos, while supermassive black holes, their relatives, predominate. These gigantic black holes can be millions or billions of magnitude as big as the Sun, yet have a diameter of around a similar scale. Black holes are assumed to exist at the heart of almost every galaxy, including our own Milky Way. Hundreds or even thousands of small black holes potentially join together to form supermassive black holes. 3. In the midway, intermediate black holes. Scientists used to believe that black holes only came in two sizes, tiny and huge. But a new study suggests that medium or intermediary black holes, IMBHs, may arise. Whenever stars in a group meet in a chain reaction, similar objects might arise. Several of these IMBHs growing in the very same area might ultimately collide in the galaxy center, generating a supermassive black hole. What do black holes look like? The inner and outer event horizons, as well as the singularities, are the three layers of a black hole. The event horizon is the border that surrounds the black hole's mouth, and beyond which no illumination can exit. A particle cannot escape the event horizon after it has crossed it. From across the event horizon, gravity remains constant. The singularity, or one place in space-time in which the black hole's mass is centered, is the inner area of a black hole in which the object's mass is also largely focused. In a process known as accretion, black holes suck in materials from their surroundings. This accreting material warms up and turns gravitational acceleration into radiation, emitting dazzling light at a wide range of frequencies, notably radio signals that can be detected by radio telescopes thanks to viscous dissipation. The event horizon is crossed by the luminous matter accreting onto the black hole, producing a dark region over a brilliant background, which is also known as the shadow. The shadow is simply a picture of the event horizon, overlaid over the light reflection in the background by the intense gravity pull surrounding the black hole. Lastly, can black holes kill our Earth or solar system? Black holes don't really consume stars, moons, or planets as they travel across space. Earth will not be swallowed by a black hole, since none are near enough to the solar system to do so. Even if a black hole the same size as the Sun replaced the Sun, Earth just wouldn't fall into it. The gravity of the black hole will be the same as that of the Sun. Earth and the other planets will circle the black hole in the same way that they currently circle the Sun. It is impossible for the Sun to become a black hole. A black hole cannot be formed by the Sun since it is not a sufficient star. Black holes have evolved from a mathematical curiosity and a strictly theoretical physics issue into a key field of astronomy study, where concept and computer models face tests and data on a regular basis. With the recent widening of the known universe force of gravity window, we may hope to discover more about the creation, existence and demise of these extraordinary entities in the coming years. We can be confident of one thing: nature's fascinating creativity will continue to astonish us.